Howdy everybody, welcome back to another lecture. My name's Todd, I'm your teacher, and we're going to do our assignment together here. This is assignment 1 from module 1, so the first chapter of the textbook. And what we're going to do here is we're going to, the first question here is what is it? So the way I got here, let me just show you how I got here, is in Canvas you go to modules, and then in modules you go to chapter 1. And in chapter 1, you click on this, and then it starts, and you end up here. So what we're going to do here is this first question: what is the average price for the phones to 2 decimals? And so here's the price of the phones right here. There's an Excel spreadsheet right here that I can work with this data. And to calculate an average, you're basically going to add up all of these data values. So there's 1, 2, 3, 4, 5, 6, 7, 8 data values. You're going to add these all up, and you're going to divide by 8. And we're going to do this both in Excel or in a spreadsheet application. Maybe I'll use Google Sheets. And then we're also going to do this by using ChatGPT. So I'm going to launch up ChatGPT, and I'll type in chat. And then in here, I'm going to say, can you please show me the formula for average or mean in statistics using the sigma notation, sigma notation. So in statistics, what that formula looks like, hopefully, was this right here. And so that's kind of like, a crazy looking deal. But it's saying sigma means, like, and this is where statistics can be intimidating, but sigma means that you're going to add everything up. What are you going to add up? You're going to go from I to n, so I being equal to 1, right? So that's like the very first data value. So if I look at this in relation to this here, like we have n number of elements here. We have n number of elements, and there's 1, 2, 3, 4, 5, 6, 7, 8, and they go through 8. So if we say that I is like a variable and it goes from 1 to n, and n is like the total number 8, this is what this notation means, okay? So I is equal to 1. We start out with the first one right here, and then we go up however many there are, and n represents however many there are. And this can be a capital N if we're dealing with a population, like every student at a school, right? The entire population of all the students at that school, that's the notation for that is capital N. And if we're dealing with just a sample of the students at a school, just 30 of the students at a school, that would be a lowercase n. So we're adding up every number, starting with the first one through all the ones that we're going to work with, and that's represented by n. And we're going to do that. We get the value for each I. Right? We get the value for the first one, we get the value for the second one, we get the value for the third one, and then we're going to divide that all by the total number. So this is crazy looking notation, and it's intimidating and confusing to students when they first see it. It was intimidating and confusing to me when I first saw it. But basically all that means, I sometimes say statistics has a inferiority complex, and it has to kind of like try to prove that it is complicated. And it's like a hard discipline and it takes work. But it's actually, we all know how to calculate an average. And they also call the average the mean, just to add to the confusion. It's a little bit pretentious, I think. But all we're doing is adding up these 8 numbers here for the price of the phone and then dividing by 8. And that's exactly what this formula shows you. So this mu is a symbol for the mean or average of the data set. N is the total number of observations in the data set. And E with the I equal 1 to N represents the sum of all the values from I equals 1 to I equals N. And XI represents each individual data in the data set. So this formula tells you to sum up all the values in the data set, x1 plus x2 plus x3, all the way up to xn, and then divide the sum by the total number of values n to find the mean. Let's do it. So I'm going to come here and I'm going to download this data set right here, and then I'm going to say, hey, show me that in Finder, and then here's that data set in Finder, and then once I have that, I'm going to go into my Google Drive, and in my Google Drive, I'm going to go into where I keep stuff for school, and that's in lectures, CIT 15. I think I put it in here just because it's one folder, so it's not the best organization, but it works. And then I'm going to create a new folder here, and we'll call this 1, 0, 1 for chapter 1. And I want to go up to settings up here, and in settings I want to make sure that I have convert uploads to Google Docs editor format. So I want to make sure that that check mark is on, convert uploads. And I'm going to convert my uploads is what that means. So as I upload something that's a Google spreadsheet or a Microsoft Excel document, as I upload that, it's going to convert it to a Google Sheets document. And as a Google Sheets document, I'm going to be able to work with it. So now I'm going to, in Google Sheets, I'm going to double click that. And here's my data. And I'm going to zoom in just to make it a little bit more legible so my eyes aren't what they used to be. And so I went up here and did that to 200%. And then here I'm going to add up each of those values. So I could do equals, and I could say, hey, this one plus this one plus this one. And notice when I click on each of the values, I'm getting the reference to the cell. I'm not getting the value. So column C, row 2, that's C2, right? And it's going to take the value that's in that cell, and it's going to add it to the value that's in C3, and it's going to add it to the value that's in C4. And so I just do this all the way. Click the operand, and then click the operator, and I missed one here, so I'm going to just delete some stuff. I'm going to go with that one. I need my C5, and then I need my C6, and then C7, and then C8, and then C9. And I don't need a plus there. So I'm going to do that. And so 545 is when I add all those up. I could also just do equals sum. And you have all these different functions. You could get to all the functions right here where you could learn more. And you can see all of them right here. You have all these functions. But I'm going to do sum, and I'm going to sum up. So I'm going to click right there, do my parentheses. And you could read about them by going back up here to this thing here, and we'll find where to read about them in just a second. So then there's sum, and I'm going to sum all that up from C2 colon C9. So what that notation means is from C2 all the way to C9, add all that stuff up. And I'll get the same thing. So I could add them up individually, right? So I'm just going to spread this out. Whoop. And I could add them up individually, or I can add them up like that. Okay, both those ways. And I'm showing my formulas and showing the results, the computations, by holding down Control and toggling, holding down Control and pressing the backtick character, which is just to the left of the number 1 on your keyboard. In the top left area, you have a backtick. And that's how you go from formula view to computed view. You can learn more about functions. I think you could do that by coming here and then learn more right here. And then when you get here, you could search for whichever function you want to learn about, and it'll explain how to use it in Google Sheets. So now that I have 545, I'm going to enter another formula. All formulas begin with equals. I'm going to say equals this divided by 8, right? And so that'll give me 68.125. I could also just do equals average, and I could choose average there, right there, and then say I want to average all that stuff like that. It'll give me 68.125. I could go up here, I could go to format, and I could choose number, and then I could choose in here to 2 decimal places. And so I could go to custom number format right there, and then here's what it looks like with decimal places. And I'm just checking this out here to see what that looks like. I guess I'll try this one and then just do 2 decimals, so just have 2 zeros there and see what that looks like. So 68.13 is with 2 decimal places. So I come back over here to my deal, 68.13, and enter that there. What is the average talk time for the phones to 3 decimal places? So come back over here, and the average talk time for each phone, I could do equals average. And average F2 through F9, it's already filling that in for me. I can press enter, and it's 8.875. 8.875, 8.875. And what percentage of the phones have voice quality of excellent to the nearest whole number? So percentage is like what percentage of a whole. 100% is the whole. You can't have more than 100%. Sometimes you'll hear people say, hey, I'm going to give 110%. That's a really nice euphemism. A euphemism is like a saying, or, you know, it means, you know, I don't know what it means. Euphemism define. So euphemism is a mild or indirect word or expression substitute for one considered to be too harsh or blunt when referring to something unpleasant or embarrassing. That's not the right word I want to use. So that's a really nice analogy. I don't know what word I want to use. Analogy. But when people say 110%, hold on, I gotta shut the door. There's a little bit of noise in the house. Just one second. So when people say 110%, they're embellishing. That's a good word. They're embellishing. Because 100% is 100%. You can't have 110%. 100% is all of everything of the entire whole. And it's like, I don't know, it's like a glass or something. It can only hold so much. When it's full, it's full. So 100%. If you have like 10 things and they're all black except one, right? Then you have one that is not black, and 1 out of 10 is 1 over 10 or 10%. So if you wanted to learn a little bit more about this, you could say, please explain to me percentage. Please explain percentages for me. And again, I think we've talked about ChatGPT, but you want to make sure that the best version is when you pay for the monthly service. It's $20 a month right now, and then you get the very latest version of ChatGPT, which, because this technology is so new, it really makes a difference. The new version is really much better than the old version, and I really recommend it. But you could see here, you could pause the video and you could read about how percentages work, in case that's new to you. And then you could pause the video and you could read about percentages here, and then you could pause the video once more and you could read about the rest of percentages right there. So to calculate a percentage, we're going to come in here and we're going to see that we have 1, 2 that are excellent, and that's out of 8. So we could come here and we could say equals 2 divided by 8, and 2 divided by 8 is 0.25. And 2 divided by 8 is also equal to 1/4. And I could say, could you please show me and explain how 2 divided by 8 is equal to 1/4, and that is equal to 0.25. Right? So that, for people where that's new, and we're going to break down how 2/8 is equal to 1/4 and how both of these fractions are equal to the decimal 0.25. Simplifying 2/8 to 1/4, the greatest common denominator of 2 and 8 is 2. So GCD is the greatest common denominator. To simplify a fraction, you divide both the numerator and the denominator by the greatest common divisor, what they both have in common. Greatest common divisor, GCD, that's what it stands for. Divide both the numerator and denominator by 2, and so 2/8, right? Divided by 2, and you could do you can multiply anything by 1 or divide anything by 1, and it's still itself. So that's a really interesting rule in mathematics. Anything multiplied by 1 or anything divided by 1 is still itself. 72 divided by 1 is 72. 109 divided by 1 is 109. 4 divided by 1 is 4, right? So if we multiply or divide 2/8 by 1, it's still going to be 2/8. And so when we do this, when we divide 2 by 2, we get 1, and when we divide 8 by 2, we get 4. So that's just a principle of math, right? So 2/8 simplifies to 1/4. Converting 1/4 to a decimal. So 1 divided by 4 is 0.25. And then you can pause the video and you could read the rest of that. So I'd come back over here to my homework and I'd enter here, it's 25%. Because 0.25 is equal to 25%. And so to get percentage, like we can come back here and say, how do I convert 0.25 to percentage? And you'll say multiply by 100, right? 0.25 times 100 is 25%. So there's that explanation if you want to pause the video and read that. So we're really leveraging both, spreadsheets and ChatGPT to help us do the homework here. I've completed this one. I'm ready to check my work. And when I check my work, I see I've got green check, green check, green check. All checks out. I'm ready to go to the next one. Sweet. So here on this next one, we've completed 1 of 6 here, and on this next one, it's asking us this. Many service companies collect data via follow-up survey of their customers. For example, to ascertain customer sentiment, Delta Airlines sends an email to customers immediately following a flight. Among other questions, Delta asks, how likely are you to recommend Delta Airlines to others? The possible responses are 1, 2, 3, 4, 5. Are the data collected by Delta in this example quantitative or categorical, right? So categorical is also known as qualitative, and quantitative would be some numeric. Quantitative is N-O-I-R, NOR. It's going to be I and R of the different data types. And so I and R are interval and ratio. And here we really have something which is more, and the interval and ratio are numeric. And quantitative is numeric, and qualitative or categorical is going to be more likely to be alphabetic, and it's going to be, we have NOIR, nominal, ordinal, interval, and ratio. And nominal makes me think a name. And so here we're dealing with something which is categorical. It's a category. Which category are you going to choose? So I'm going to go with categorical. Boom. And what measurement scale is used? Select your answer. So here we have ratio, interval, nominal, and ordinal. So the way I remember those is film noir, N-O-I-R, and it goes nominal, N-O-I-R, ordinal, interval, ratio. And nominal is just like a name. Ordinal is a name with rank. So like, AAA, triple B, triple C, there's a rank to that. And here we have a ranking, right? Like these could be, this is better, this is worse. So because it has a rank, it has an order, I'm going to go with ordinal. Now before I submit this, and I don't know if I have this right? Like, I'm relatively new to statistics. Taken it twice, I've taught it once, this is my 3rd time. Before I submit this, I'm going to take a picture of it. So I'm taking a picture of it with my phone, boom, and we'll see if this picks up. But now I'm going to go to ChatGPT on my phone, and I'm going to upload that picture. So I'm going to select that picture, and I'm going to upload that to ChatGPT, and I'm going to ask it, did I answer these 2 questions correctly? Question mark. And I'm going to submit that to ChatGPT. And when it's finished answering, I'll be able to come over here and refresh because it's the same account. And now it's answering. So when that answer is done, I'll refresh and bring it up over here. So I'm going to just come back up here and hit refresh. And we should see that show up, data type and scale. So here's the image I uploaded, and we can just take a look at that image. So it's a little bit hard to read, but hopefully ChatGPT read it. It says, yes, your answers to the 2 questions appear to be correct. Data type. You correctly identified the data as categorical because the responses fall into distinct categories. And measurement scale. You also correctly identified the measurement scale as ordinal because the categories have a logical order or ranking from definitely will to definitely will not. These answers align with the correct interpretation of the questions. Great job. So now I'm going to check my work. So check my work is right here. And I got green and green. I'm going to hit next. And one of the things you're really seeing here is how you can leverage tools, whether it's a spreadsheet or ChatGPT, to help you do your work. Based on data from the U.S. Census Bureau, a Pew Research study showed that the percentage of employed individuals ages 25 to 29 who are college educated is at an all-time high. The study showed that the percentage of employed individuals with at least a bachelor's degree was 40%. The percentage was 32% in 85 and 25% in 64 is only 64 is only 16%. What is the population being studied in each of the 4 years in which Pew has data? Employed individuals in the U.S., unemployed individuals, employed and unemployed individuals in the U.S. So we're looking at employed individuals, right? So employed individuals ages 25 to 29. Right, is what question was posed to each respondent. At what age did you have you earned a bachelor's degree or higher? Do responses to the question provide categorical or quantitative data? Right, so are we getting numbers here or are we getting some sort of a category? And the category is educated, not educated. What degree of education do you have? So I'm going to say it's categorical. It's category. It's qualitative. And I could again upload this chat GPT, or I could just hit check my work. That all looks good, and I'm going to move on to the next one. So here we have a Gallup poll utilizing a random sample of 1,503 adults, 18 or older, was conducted in that date. The survey indicated a majority of Americans say driverless cars will be common in the next 10 years. The question asked was, thinking about fully automated driverless cars that use technology to drive and do not need a human driver, based on what you have heard or read, how soon do you think driverless cars will be commonly used in the United States? The figure below shows a summary of results of the survey in a histogram. So a histogram is just a bar chart without spaces between the columns, indicating the percentage of the total responses in different time intervals. So again, a histogram is a bar chart without spaces between these columns. So are the responses to the survey question quantitative or categorical? That's a good question. So are we dealing with numbers here, or are we dealing with categories? We got a certain number of people in each category. And I'm going to say that we're dealing with categories. So, choose your category is what I'm thinking. How many of the responses said that they expect driverless cars to be common in the next 10 years? Round your answer to the nearest whole number. So how many of the responses within the next 10 years? So here we have within 5 years, within 6 to 10 years. And within 5 years, 53% will be common in the next 10 years. How many of the response said that they expect driverless cars? Round your answer to the nearest whole number. How many of the respondents said they expect driverless cars? Well, there's 53 respondents out of 1,503. So I'm going to say 1,503 times 0.53. And that will give us 796, and I'm going to round that up to 797. So I don't know if that's what they're looking for, but that's what I'm going to put in, 797. And we'll just check to make sure I got the right number there, 797, yeah. And here we have the percentage, and they want a quantity there, how many. How many respondents answered in the range 16 to 20 years? Round your answer to the nearest number. 16 to 20, that looks like it's right at 10%. So 10% of that is going to be 150.3. So we'll just put in 150. And we're going to check the work. Again, if I wanted to have this explained to me, I could take a picture and upload it to ChatGPT, and it'd give me an explanation. And let's see. So I didn't get categorical correct on that, which is fine. And I'm actually kind of happy I got one wrong, because one, it's good to show that not everybody knows everything, and that we're all human, and that we're all always learning, and we're learning here together. And statistics is something, the second point, statistics is something where you kind of have to it's not just cut and dry, you have to think about it. And we were putting people into categories here, so we had people choose which category do you fall in. But the number that they were choosing is is a number, it's quantitative. I don't know. I'm still on the fence about that. So I'm going to check my work again. And here it's showing correct. And now I'm just going to move on to the next one. And then also, if I wanted to, I could take a picture of that incorrect one, upload it to ChatGPT, and get the explanation. So that's also handy. 7-year medical research study reported that women whose mothers took the drug DES during pregnancy were twice as likely to develop tissue abnormalities that might lead to cancer as were women whose mothers did not take the drug. The study compared two populations. What were the populations? I wouldn't say they're populations, because I wouldn't say mothers who took the drug. Maybe could they have compared all the mothers, right, who had kids who did not take the drug? That's every mother in the world. And I'm thinking it's the samples would be a better. What were the samples? And by the way, there are errors in the textbook, which I found. So that's just human. And even when you have the smartest people in the world creating content, they make errors. And so here, so this could be an example of one of those errors. Instead of what were the populations, it could be what were the samples. So it was two types of DES that caused no. Women with tissue and women no. Women whose mothers took DES and women whose mothers did not. Women who developed that's the one we want. Do you suppose the data were obtained in a survey or in an experiment? And so, it depends, right? Like a survey would just be surveying moms who didn't take it and then surveying moms who did. An experiment would be designed. Let's give people stuff. I think they were just observing the world as more of a survey. For the population of women whose mothers took the drug, a sample of 39 showed that, so here it is, a sample, right? 63 developed tissue abnormalities that might lead to cancer. Provided a descriptive statistic to 1 decimal that could be used. And a descriptive statistic just means it's a statistic which describes something in the world. So it's unnecessarily pretentious and complicated but that can be used to estimate the number of women out of 1,000 in this population who have tissue abnormalities. So used to estimate the women out of 1,000 who have tissue abnormalities. So the population of women whose mothers took DES during pregnancy, a sample showed that 68% developed abnormalities. Provide a statistic that could be used to estimate the number of women out of 1,000 in this population of tissue abnormalities. And so I would say that this should be who developed tissue abnormalities, because people could have tissue abnormalities without ever taking DES, and those could be people in this population. So that was like poorly worded, but down here it says developed tissue abnormalities, which sort of hints at they took DES and then developed. So out of 3980, 63 developed. So we'd say 3980 divided by 63, right? And so if we had like, sorry, it should be 63 divided by 3980, like that. 63 divided by 3980. And then multiply it by 100 to get a percentage. If it's asking for a percentage, let's see what it's asking for. And out of 1,000 developed tissue abnormalities. So we'll multiply it by 1,000. So it's that percentage multiplied by 1,000, which means that it's 15.8 or 16. And you can't have fractions of people. So 16 out of 1,000 developed tissue abnormalities, is what that's saying. So 63 divided by 3980, like if you had 10 out of 100 or 40 out of 100, that gives you 40%. So 63 out of 39.8 gave us, this number here, 63 divided by 39.8. And then when we multiply that, so that is like, this percentage of people, or that fraction of people have tissue abnormalities. And when we multiply that by 1,000, we get the number of people out of 1,000, which is rounded up to 16. And then here we have, for the population of women whose mothers did not take DES, what is the estimate of the number of women out of 1,000 who would be expected to have tissue abnormalities? Hint, for the population whose mothers did not take DES, what is the estimate of the number of women who would be expected to have tissue abnormalities? Remember that women whose mothers took the drug were twice as likely to develop tissue abnormalities. So we'll say 8. If it doubles it, right? If DES doubles it to 16, then this is going to be 8. True or false? Medical studies often use a relatively large sample because disease occurrences can be rare and difficult to observe when isolated populations are considered. I have no idea, but I'm just going to guess true. Check my work. 8. Okay, so didn't get these correct. And now I could do this. So I'm going to take a picture of my screen, and I'm going to upload that to ChatGPT. Can you please explain why I did not get these 2 questions correct? Question mark. And when this is done creating the answer, we'll read it. So let's create the answer. Oh, so maybe I got the rounding error off. So here they came up with an answer of 15.8. So maybe I just thought you can't have fractions of a person. And where does it say what I round to? To 1 decimal, right? So to 1 decimal is going to be, to 1 decimal is going to be 15.8. So that's what we needed there. So I'll put 15.8, which means that this one is going to be 7.9. 7.9. And we can just check that here. So you can pause the video. And you can read this one here. And so 15.8 is what they're saying should have been entered. And you can pause the video and you could read this one here. And it's saying 7.9, because 7.9 doubled is 15.8. Now I'm going to check my work. And I've got those correct. I'm going to go to next. And then finally for this one here, we have a lot. So let's read through it and do it. Consumer Reports evaluates products for consumers. The file, compact SUV. Click on the data file logo to reference the data. So I'm just looking for a data file logo, but I'm not seeing one anywhere. Data file logo. I don't know. Oh, here it is, right here. Data file logo. Contains the data shown in the table below for 15 compact sports utility vehicles. With this information, how many variables are in the data set? So the number of variables in the data set is equal to the number of elements times the number of variables. But I'm not totally clear on whether or not like the nominal element name is considered one of the variables. I think it should be. If that's the case, then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 elements times 1, 2, 3, 4, 5, 6, 7 variables. 15 times 7 is 105. And 105 would be, 105 would be the number of variables in the data set. Well, that'd be the number of pieces of data in the data set. So this would be the number of variables is 1, 2, 3, 4, 5, 6, 7. So we'll go 7 there. We'll go 7. Which of the following variables are categorical and which are quantitative? So for categorical, overall score, I'm going to do that one quantitative. Recommended is going to be category, it's yes or no. Owner satisfaction is going to be categorical, it's going to be ordinal, it has a rank to it. And overall miles per gallon is going to be quantitative, and acceleration is going to be quantitative. What percentage of these vehicles are recommended? Round your answer to 1 decimal place. So I'm going to download this data file now, and then I could open that, and I'm going to drag it back up in here and convert it. So put it back into Google Drive, and it converts to a spreadsheet. And then I could open that, and what percentage, what's the question? What percentage of the 15 vehicles are recommended? So recommended. So come back over here, and we'll go to 200% here. And we'll say recommended. We have 1, 2, 3, 4, 5, 6, 7. We have 7 out of 15. So it equals 7 divided by 15. And that's like 46.67%. And what do they want it to? 46.67 is 46.7. And what is the average of the overall miles per gallon across all 15 vehicles? So here we'll do average. And the average of miles per gallon will just come here. And we could come up here and we could choose average this way. And then we could say, make all of that. Give me the average of all of that. And the average of all of that is 24.4. And of course, you want to know in your mind when you're calculating the average or the mean that's all of these items. Let's make sure I got that right. F2 through F16, that's correct. It's all of these items added up and then divided by the total number of items, which in this case is 15. So 24.4 goes here, 24.4, and it's to one decimal place. Cool. For owner satisfaction, select the bar chart. Choose the correct bar graph from the above diagrams, owner satisfaction. So we're just looking here to see which is the correct one. And if we look at the data, here's owner satisfaction. We have like, what, 3 double pluses, and we have 4 pluses. So we'll just come back over here, and we're looking for 3 double pluses. So here is like 20, here's like, oh, what percentage is 3 out of 15? 3 out of 15 is 5%. Is that right? 3 out of 15 is 5%. 3 out of 15 equals 3 divided by 15. 3 divided by 15 is 20%. And so we need the double pluses to be at 20%. That's right here. And then we had, here we had 1 plus. And so 1 plus, hey, yeah, it is. It's right here. There you go. You're welcome. For 4 pluses equal to 4 divided by 15 is going to be 26.67%. And so that's like 26.67%. So we're going to say it's B, right? So B is the one we're looking for there. And show the frequency distribution for acceleration using the intervals. Round your answers to the nearest whole number. So frequency distribution, here we have these different categories. We have 7, 8, 9, and 10 are basically the categories. And so the acceleration, and you know, we could do like, that's a little bit more complicated, but we'll just do 7, 8, 9, and 10. And then we're just going to take these and put them over here, Control C, and we'll put them just, yeah, I guess we'll just do them here, Control V. And so we have, let's just start out with 7s. We got 1, I'm just going to delete them as I go, and I only see 1. I only see 1 7. And then for 8s, we have 1, 2, 3, 4, 5. So we have 5 for the 8s. And then for 9s, we have 1, 2, 3, and 4. And then for the 10s, we have 1, 2, 3, 4, 5. So our frequency distribution is like, you know, 1 is at 7 to 8 seconds, 5 are at 8 to 9 seconds, 4 are 9 to 10 seconds, and 5 are 10 to 11 seconds. And so if we come over here, we got 7, 8, 9, 10, 7, 8, 9, 10, 7, 8, 9. So it's all left to right, 7, 8, 9, 10. And 7 is 1 and 8 is 5. So 1, 5, 4, 5. 1, 5, 4, 5. 1, 5, 4, 5. So it's this one here, D. D. All right, so now we can check our work and see what we got wrong. And how many variables are in the data set? And then we got that one wrong. Oh, and we forgot to enter these. 1, 4, 5, 4. Right? 1, 5, 4, 5. Sorry. 1, 5, 4, 5. And then I'm going to come up here. I'm going to take a picture of this because I'm curious. And we'll snap that. And we could even get this in closer. And then I'll upload both those images to ChatGPT. So you could upload more than one image. I'm going to upload them both because I got a close-up of the picture. And how many variables are in this data set? Question mark. Do you include the make and model in the data set? Curious. I'm not sure if you also include the element's name as a variable. Okay, so let's ask that question. See what it says. So it's uploading, and when it's done uploading, we'll take a look at the answer. And by going through this homework together, I'm hoping that you're kind of like, you know, seeing how I work with ChatGPT and spreadsheets, and you're learning more than just statistics here. So it says there's 7 variables in the data set, which is what I thought, right? And 7 right here. How many variables are in the data set? And make them all are typically considered variables in this context as they represent specific characteristics of each element, despite being identifiers. Therefore, they should be included when counting the total number of variables. Yeah, what do you know? So we got 7 wrong. How many variables are in the data set? So maybe we could just try 6, see what it says with that. Like, you know, whatever. And we could try 5. Check my work. And it likes 5. So 1, 2, 3, 4, 5. It doesn't like having the make a model, the identifier of the element as one of the variables. Okay. And now that's it. We can submit an assignment for grading. Would you like to submit and exit? Yeah, submit for grading. So I'm kind of curious. Assignment finished. Your assignment has been submitted to your instructor. You scored 100%. So that's great. Like even when I went and I changed stuff and then redid it, it gives me 100%. So I really like that. Hey, that was kind of fun. I hope you enjoyed it and I hope you learned something. See you next time.